Why, hello, it's me again. We are on to another day of word problems, quadratic word problems that is. And remember, I want you to be able to understand what the word problem is asking. I want you to be able to set up the necessary equation and process. I want you to actually solve the equation or use your calculator to solve it. And I want you to be able to state the answer in complete sentence form. So, example number 1. The Empire State Building is 1,250 feet tall. If an object is thrown upward from the top of the building at an initial velocity of 38 feet per second, its height s seconds after it is thrown is given by the function h of s. So they're using s for seconds instead of t for time. That's okay. So negative 16s squared plus 38s plus 1,250. How long will it take for the ball to hit the ground? So at this point, you should be experts. You should be little mini experts at this. So you need to think, okay, it's an opening down parabola. It has a starting height of c of 1,250. And it's thrown upward and it's going to come back down like this, okay? And it says, how long will it take for the ball to actually hit the ground? So here it's getting thrown. So you got this ball, it's like, oh, here's where it'll hit the ground. So you want this time that happens because it says how long. Okay, remember this is the t-axis, this is the h-axis. Actually, no, they call it s-axis here. So this is the s-axis, you want the time, the s, okay, and this is the height. So we ultimately want this, okay? So how do we set this up in our calculator? Well, in y1, we put negative 16x squared plus 38x plus 1,250. And remember, what do we want? This is an s-intercept. An s-intercept, which means the height is what? When it hits the ground. What's the height? Where are my feet right now? They're at h equals 0. So we want the height to be 0, which is like y. So what are we going to put in y2? We're going to put a 0. So grab your calculator and let's do it. Go to y equals, clear out whatever's in there. And y1, type negative 16x squared plus 38x plus 1,250, enter. And in y2, put 0. Now, if you have one of these calculators, you won't see it graph two different lines. If you have one of those fancy dancy, wonderful ones that have different colors, you will see, oh wait, hit zoom 6. You will see that it's actually graphing two lines. All I see is this start of the parabola right here. And then what I know though in y2, I put a 0, so that means that right here it graphed a line right along the x-axis, and in terms of this problem, the s-axis. Now, that's wonderful, sort of. I need to see this part of it, and I don't see that at all. So I need to go to my window. Remember, we went to zoom 6, so we're all on the same playing field. Now we need to go to the window, and what do we need to change? We need to see this over here. So on the calculator, that's a higher x value that we need to see. So we go to window, we want to change the x max. Now I'm thinking something large. I'm not sure. You play with it and see. All right, I'm going to put 200. So in x max, I put 200. I hit graph, and if I'm wrong, I can figure out, oh, that was like way out there. I did not need to go that far, but it'll be okay. I can still see where it hits the axis. Now that does make me feel a little uncomfortable, so I'm going to go back and maybe make my x max 50. Let's make the x max 50. Yeah, I can see it a little bit better here. See that? So I changed my x max to 50. I probably could have changed to something smaller. But the bottom line is this. I'm trying to find this point. So I hit second calc. You should be able to tell me this now. Intersection. So second calc, number 5 for intersection. Now, it's going to go first curve, second curve, yes. When you're doing intersection, what you want to do is you want to move Blinky Man right where you want to find the intersection point. The calculator graphed this parabola and it graphed this line right here. You may not have seen it, but it did. So we want to move Blinky over to this point. Now I can't see Blinky Man right now, so at the up arrow, I can see him now. He's right there. And I'm going to move him over on top of the intersection point that I'm trying to find. As close to it as I can get. Once I move Blinky, I hit enter 3 times. So move Blinky Man to the intersection point, and then you hit enter 3 times. I feel like a broken record. So enter, 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 and I get 10.11. So this right here, this point right here is 10.11 comma 0. It better be. So how long will it take for the ball to hit the ground? It will take 10.11 seconds. Okay, so it'll take 10.11 seconds for the ball to hit the ground. We just did that one. Now on to the next example. It's actually number 3 on your worksheet. It says a ball is thrown straight up with an initial velocity of 56 feet per second. The height h of the ball is given by t seconds. We know this. All right. Now look, it's not in standard form, but that's okay. We can leave it like that. If it makes you uncomfortable, you can rewrite it as negative 16t squared plus 56t. Notice the 56 in place of the velocity because it should be. There are 3 parts to this. Part A, what is the maximum height? Now let's think about it. Did this ball start? Where did it start? What is C? C is 0. So that means that the starting height was 0. So it was like this. And it wants the maximum height. So what do we want? We want this point right here. That's what we want. We want the maximum height. Now we want this is T axis or X as you're used to. This is H or Y, but we're going to get an ordered pair here. We want the Y value or the height value because it wants the maximum height. So I go to Y equals, clear out what's in there, negative 16x squared plus 56x. I'm going to clear out Y2. I don't need that. I don't need that. I'm going to hit zoom 6 so we're on the same page. So I zoom 6 and there it is. I can see where the parabola goes up and comes back down, but I actually need that high point. So I'm going to go to window and change my Y max. So Y1, I put the function. And then I'm going to go to I got to see it. I'm going to hit graph. And then I'm going to change my Y max to something larger. If you were in here, I'd ask you, what do you want to change it to? I'm thinking, we're already up to 10, so I'm thinking maybe change it to 20. Oh, let's do 30. Let's just do 30. So Y max 30. Not quite enough, you see that? So I need to go back, hit window, and change my Y max to maybe 50. So I just changed my Y max to 50. All right. There it is. I can see the whole thing. So I changed my Y max to 50, and I can see that maximum point. So I hit second, calc. What do I hit? I hit maximum. I want to find the maximum. So second calc, maximum, which is number 4. Now it's going to say left bound, right bound, and guess. Remember, what you do here is when it says left bound, you want to move Blinky to the left of that maximum point and hit enter. So right now, you're going to move Blinky. Now, he's right there. So I'm going to hit the right arrow and move him to the left of that maximum point. Once I move Blinky to the left, because it says left bound, I hit enter. So your next step here is move Blinky Man to the left of max point, okay? And hit enter. Then it's going to say right bound. So then you move Blinky Man to the right of the max. So I've got to move Blinky to the right. So I move Blinky. I don't even know if you can see this. I'm trying. You move Blinky to the right. There he is. And then hit enter. Always through guess, you hit enter. So you're going to hit enter again. So enter. And it'll calculate it for you. It just told me that that maximum is 1.75 comma 49. Now, we're still on part A, and it says, what is the maximum height? So what is it? Is it 1.75? No, because that's time. It occurs at 1.75 seconds, but the maximum height is actually 49 seconds. Okay, part B. What is the height of the ball after 1 second? Okay, so I want to talk about this because we actually, in class so far, have not done this little trick on the calculator. It wants to know the height after 1 second. You could just plug 1 into that and get the answer. Okay, super simple. You get 40. Okay, 40 feet. And that's great and fabulous and wonderful. But I want to show you if it's not that easy. So we basically want to go, something you can do for part B is you can go to second calc value. We're trying to find a value. So second calc value is number 1, so hit 1. What this is data entry mode. We want when time is 1. So we want when x is 1. See that x equals? We put a 1 there and we hit enter and it tells me the height. So we put 1, we hit enter, and we get our answer of 40 feet. So part B is 40 feet. Or again, like I said a minute ago, you can just plug 1 in here and here. And that's great. And that's what we were doing in Unit 1. We were doing function notation. We were plugging 1 in, okay? They both work. Part C. After how many seconds will it return to the ground? Okay, we want this. You should be old school. We should be good at this now. We already have the function in Y1. But what do we want to put in Y2? What's the height when it goes back to the ground? It's 0. So you go to Y equals, and in Y2, you put a 0. You hit graph, it's going to look the same. So now, unless you have one of those color ones, it'll show you a new line right there. We want to calculate that intersection point right there. So we go second calc intersection point, second calc 5, and then move Blinky over here where you want it. So I'm going to hit the down arrow and just move him over. Blinky needs to go right on that intersection point that you want, okay? So I'm going to move Blinky right here to that intersection point. And then what do? You hit enter 3 times. Enter, enter, enter. So enter, enter, enter. And I just got that is right here, 3.5, 0. So what does that mean for part C? It means after 3.5 seconds, it will return to the ground. There you go. There you go. Alrighty. So I hope that helps. Have fun. Be good.